Okay, so today we're going to talk about two different forms of lines. And again, this is all Algebra 1 review stuff, so this is stuff that you have seen. Okay, so the first one is our slope-intercept form. So I want you to write this down. Y equals mx plus b. Y equals mx plus b. Okay, so in this form, what does the m stand for? Or what does it represent? The slope. What does the b represent? Good, it represents the y-intercept. What does y-intercept mean?
On the y-axis.
It's where it crosses the y. That's what intercept means, is like cross paths. It's where the line crosses paths with the y-axis. Okay? All right. So number one says write the equation with that information, then graph it. So the slope is 3, and it has a y-intercept of -2. So if I take that information and put it into the slope-intercept form, what's it going to look like?
Y equals 3x minus 2.
Good. Y equals 3x minus 2. Right? The slope goes right here. The y-intercept goes right there. So that's my equation. Now what I want to do is graph it. Okay. So to graph that equation, what do I want to start with?
The y-intercept.
The y-intercept. Okay. So where does this one cross the y-axis at? At -2. So what I'm going to do is go to the y-axis right here. I'm going to go along there until I find -2. So there's 0. Boom, boom. It's right there. Okay, so this line I'm about to draw goes through that point. Now, I don't know which way it's going to go right now. I don't know if it's going to be here, 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 whatever, but I do know that it goes through that point. How am I going to find some more points on this line? Okay, I know one point. How am I going to find some more points? What am I going to use to find some more points on this line? The slope. And the slope, it said, is 3. Okay? So if it's just 3, then that means I go up 1, 2, 3, like that. Is that what that is? No, because if you think about it, if I draw that line right there, what type of slope does this vertical line have? Undefined slope. But we said that this line has a slope of 3. So where I put that second point is not right. Okay? So what is the slope of 3? Okay, good. So how can you make a whole number into a fraction? By putting it over 1. So that's how this works. So from my y-intercept of -2, I'm going to go up 1, 2, 3, and I'm going to go to the right 1. And then from those 2 points, that's good enough. I can draw my line from there. But what I'm going to do is I'm going to go ahead and just count the slope several more times. That way, especially for y'all who don't have a tool like I do here, I'll give you where you can draw the line better. So up 3 over 1, up 3 over 1, up 3 over 1. Let's give you some more points on that line. Make it easier to see where that line needs to go. Okay, number 2. What would that equation look like?
Y
equals -1/2 x plus 2.
Be careful. Oh, you skipped 2.
Oh.
Plus 8. All right, so what do I want to start with on that one? 8. Go to the y-axis and go up to +8, which is right here. Now, how am I going to find some more points on this line? I'm going to use the slope. What's the slope? 1 over 2. So what is -1/2 going to do? Down 1, right 2. So I'm going to go down 1, right 2. And then I'm just going to keep doing that over and over again to get some more points. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So I should get something like that. Okay. So I want you to think about this. The equation from number 1, the equation from number 2. Just looking at it on the graph. Are these two lines perpendicular? Remember, what does perpendicular mean? We talked about that yesterday, 90 degrees. Is this blue line and this red line, are they exactly 90 degrees to each other?
No.
It looks pretty close right there. That looks pretty close to being a 90-degree angle, like right here. How would I know for sure if it's perpendicular or not? Look at the slope, right? So on the first one, the slope was 3/1. On the second one, the slope is -1/2. Are those two going to be perpendicular to each other?
No.
No, they're close though. If the top one would have been 2/1, which that's just changing about 1 unit, then yes, those would be exactly perpendicular. But since it's 3/1 and -1/2, they're close but not exact. So that angle is close to a 90, but it's off by a little bit. Okay, so those are not perpendicular. All right, the third one. Okay, so what would that equation look like? Hello?
Sorry to interrupt.
You're good. All right, what would that equation look like? Okay, good. So y equals -1/2 x plus 2. So where am I going to start at with that equation? At 2. Where?
On the y.
On the y-axis. So we're right here. Then how am I going to find some more points on that line?
Using the slope.
Using the slope of -1/2. So what's that slope of -1/2 going to do?
Down 1. Like
Down 1, right 2. Good. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Alrighty? So we already said 1 and 2 are not perpendicular because these are not opposite reciprocals. What's up with line 2 and line 3 though? Okay, good. They are parallel. Are you saying that just because they look like they're parallel?
No, because their slope is the same.
Good. You're saying that because of this right here. They both have a slope of -1/2. So just because they look like they're parallel, that may get me to start thinking about that, but that's not good enough to prove it. This right here lets me know for sure those two are parallel to each other. Okay, so y equals mx plus b is slope intercept. The other one I want to look at today is point slope. Okay, I want you to write this down. Y minus y1 equals m times x minus x1. Is this ringing a bell from Algebra 1? Hopefully so. Okay, so when we use this form, all right, this y and this x are going to stay as y and x. We're not substituting in anything for this y and x. Those stay like that. So this is point slope form. What that means is we're given one single point on the line and we're given the slope of the line. So that's where the x1 and y1 come from. That's the x value and the y value from that one single point. And then the m is the slope, obviously. Also, I want you to notice that there is a minus built into the form. Okay? So that's going to go there automatically regardless of what else I might put after it. So on number 4, I'm going to have y minus, okay, y1. So this is the y value from the single point that I've got. And so on number 4, I have the slope of 3, and 1 point on that line is at 1, 2. So y minus, what's going to be my y1 value? Good. It's 2. It's that y value from that point equals what? 3 the slope times x minus 1. Okay, and that's all we're doing here. It says just put in point slope. We're not doing any converting or anything, just want to put it like that. Okay, number 5. What would that look like?
Y minus
Good. All right, so again, the y value is 5. That got plugged in right there. The slope is 2. That got plugged into the m. And then 4 is the x value. That gets plugged in right there. So that's that information in the point slope form. Okay, number 6. What's that going to look like?
Y minus 4.
Okay, y minus negative 4 equals
Negative 1/2.
negative 1/2.
X minus negative 3.
Okay, good. Now remember, there's a minus built into the formula, or into the form, okay? So that goes there automatically. And then if there's a negative 4, then we're going to have this situation right here. So what happens when we have two negatives stacked like that? Becomes a positive. So what I'm going to do is I'm going to clean this up and rewrite it as y plus 4 equals negative 1/2 times x. Two negatives are also plus 3. So what I'm going to do for the rest of today, instead of me writing two negatives like this, I'm going to go ahead and put a positive there. So like say me having to write an extra step here. So everything else we're going to do today, I'm just going to write it like this, go ahead and put the positive in place of those two, that minus negative. Okay? So, Jalen, what would number 7 look like?
Like with the positive,
Yep.
y plus 5 equals 0 4 x minus 4.
Good. All right, on the back. So I want to do the same thing here, but we're also going to graph it, okay? So on this equation, the slope is 3/4, and a single point on that line is negative 2,5. So what's that going to look like in our point slope?
Y minus 5 equals negative 3 over 4 x plus 2.
Okay, good. Now what I want to do is I want to graph this. And to graph it, these are kind of unrelated, but I'm not going to use this. That really doesn't help me. What I'm going to do is just go back to this information right here. Okay? So again, in the point slope, I'm given one single point on the line, and then I'm given the slope of the line. So what I'm going to do is I'm going to start off by plotting that point. So negative 2, 1, 2, 3, 4, 5. So that negative 2,5 is just 1 point on this line. And so at this point, I know the line's going to go through there. I don't know exactly what's going to happen, but I know that's 1 point on that line. So what do you think we might do to find some more points on that line now?
Negative 3, plugging the down 3 over 4.
Yeah, just use the slope, right? Like we did before. So this time I'm starting at this point, and then I'm using the slope of negative 3/4. So what is that slope of negative 3/4 going to do? Yep, down 3, right 4. So from that point, down 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. All right, number 8. What would that look like in the point slope? Y plus 5 equals 2/3 x plus 5. Okay, good. All right. So again, negative 5 is one single point on this line. So I'm going to plot that point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. Go up 2. 1, 2, 3. 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. All right. And then for number 9, so what's that one going to look like in point slope?
Y plus 1 equals 2/3, and then x plus 1.
Okay, thank you, sir. That's good. So we cross at -1, a point is at -1, -1, same slope of up 2 over 1, 2, 3, 1, 2, 1, 2, 3, 3 like that. All right. So what's the relationship between number 8 and number 9 there? Okay, they're parallel again. Why are they parallel? Okay, because they have the same slope. All right. So one more thing I want to do real quick is we're going to put it in point slope and then we're going to convert it to slope intercept. So on number 10, okay, I've got slope, I've got a point on that line. So what's that going to look like in point slope?
Y minus 1 equals 3x minus 1.
Okay, good. So it's going to look like that. So this right here is in point slope form. All right, so we've already got that. What I want to do now is I want to take this and I want to convert it into slope intercept, where I've got y equals mx plus b, like the first thing we did. All right. So to get it into y equals mx plus b, I want to get the y by itself. All right, so what do you think? Well, the first thing we need to do here is we need to distribute this 3. All right, so I'm going to have y minus 1. If I distribute that 3, what is that going to give me over here? 3x and then minus 3. Right? Doing that claw thing to get that. Okay? At this point, do I have y completely by itself? Is y completely by itself here?
Oh, no.
Nope, I need to take care of one little thing. What is it? That -1 right there. So how am I going to get rid of that? Okay, I'm going to add 1 to both sides. Okay, what happens right here? Zero's out, so that leaves y equals 3x minus 2. And at that point, now I've got that in slope intercept form. That's what I want.